Hey guys, welcome to a new video. In today's video we're going to look at a Leetcode problem, and the problem's name is path crossing. So in this question we are given a string called path, where each character inside that string path is either going to be north standing for N, S standing for south, E standing for east, and W standing for west. So we start with the origin, so x comma y starts from 0 comma 0, and then we start our walk placed by path, and in each move we move either one unit north, south, east or west. So our task is to return true if the path crosses itself at any point, else we have to return false. So let's take the first example. So input string path is NES, so we start with the first character. It is north, so we move one unit north. So here we are at 0 comma 1. Then in the next iteration we are at E, we move one unit to the right, so we are at 1 comma 1. And then in the next iteration we are at south, so we come down by one unit, so we are at 1 comma 0. And here you can see, so this is representing north, this is representing east, and this is representing south. So here we do -1 for south. This is x comma y, this is x comma y, this is x comma y, and this is x comma y. So we do +1 for y coordinate. So we move one step to the right, so we do +1 for x coordinate, and here we do -1 for y coordinate. And nowhere you can see the points meeting its previous points, so we return false as the output for the example 1. Now let's take the second example. So the path is NES WW. So for N, we move one step to the north, so this will become 0 comma 1. For east, we move one step to the right, so this will become 1 comma 1. For south, we move one step down, so we do -1 for y coordinate, 1 comma 0. For west, we do -1 for x coordinate, and we reach 0 comma 0. And again west, we do -1. So this will become -1 comma 0. So we'll notice that if we do for north, we do +1 for y coordinate. If it is south, we do -1 for y coordinate. If we are moving left or right, if we are moving right, that is east, we do +1 for x coordinate. If it's west, we do -1 for x coordinate, which will move it to the left. So this is an important observation. And our main task is to check if there is at any intersection. Here, as you can see, initially we start off at the origin 0 comma 0, and here in this operation again we reach 0 comma 0. Since we already reached that point, we return true as the output. So we are going to start with 0 comma 0 and then move our way according to the path directions from left to right, and we keep building each point. Like here we build the first point, here we build the second, here we build the third, here we build the fourth, and here we build the fifth. Each point we are going to push it into a hash set because it will check for duplicate coordinates. At one point of time, when you find a coordinate already present inside the hash set, we can return true as the output. So here we start with 0 comma 0. Next we push 0 comma 1 because it is not present. Next we put 1 comma 1 because it's not present. Next we push 1 comma 0 because it's not present. Next, when we try to push 0 comma 0, it is already present inside the hash set, so we return true as the output. So whenever you encounter an element which is already present inside the hash set, return true. Else, after we push all the elements and you don't find anything, like in this case, you return false as the output. Now let's implement these steps in a Java program. So I created a hash set and started off with x and y coordinates at 0, and I'm building a string. So let's declare the hash set first, which will store strings. So first let's build the hash set. 0 comma 0 will be appended at a string and add it into the hash set because we are starting at 0 comma 0. Now we iterate through the path, which is the input given to us here. So let's take this example. We are starting with the input and we are converting the string into a character array. So this will become NES WW. Now we extract each character at a time. We start with here. So I will be here in the beginning and will reach the end using this I. Now if it is a n, we have to increment the length by 1, the y coordinate by 1. So I'm incrementing y by 1. So x is initially 0 and y is initially 0. Y will become ++ because it is north. So update 0 to 1. Now I'm building the coordinate 0 comma 1. Check if 0 comma 1 is present inside the set. There is no 0 comma 1 inside the set. It won't return true, and we add that coordinate into the set. So I'm adding 0 comma 1 into the set. Now go to the next element. Next element is a E. So here E, we have to move it one step to the right. So this is +1. So this is +1 of Y. This is +1 of X. So increment 0 to 1 for X coordinate. Now build the coordinate 1, 1 as a string. Check if 1, 1 is present inside the hash set. No, it's not present. So add it into the hash set. In the next iteration, I will move forward. Next iteration, I is at south. So here we have to do -1 for Y coordinate because we are moving down. So here we are doing Y minus minus. So Y will become 0. And check now 1, 0. Check if 1, 0 is present inside the set. No. So add 1, 0 as a fresh coordinate into the hash set. In the next iteration, I is at west. So here we do -1 for X coordinate. Because it's west, we do -1. So X will become 0. And now form the coordinate 0, 0 as a string. Check if this is present inside the hash set. Yes, it is present. So this condition satisfies and we return true as the output. So true will be returned as the output for this example, which is matching here. So the time complexity of this approach is O of n because we are iterating through the string from left to right. So n is the length of the string. The space complexity is also O of n because we're using a hash set to form the output. That's it guys. Thank you for watching and I'll see you in the next video.